Hi, everyone, and welcome to another episode of Pathfinder by Payload, the leading digital media company in the space industry. I'm your host, Mo Islam, and today we're joined by Erik Palitsch and TJ Ronacher, co-founders of Freeform. Freeform is a startup out of LA building metal 3D printing technology to manufacture high-quality metal parts at mass production scale. We cover a ton on the show today, everything from first principles thinking and building the factory of the future, how metal 3D printing has evolved over the last decade and where it's going, and learnings from their time at SpaceX. Let's get started. Erik, TJ, very excited to have you guys on the show. Welcome.
Thank you. Pleasure to be here.
Yeah, great to be on.
TJ, I want to start with you because if you Google Erik, a ton of things come up, but with TJ, not so much. Like there's articles, obviously Freeform articles, but I want to learn a little bit about your background. Why don't we start with you before we even talk about Freeform? Maybe talk about your career up until you guys started the business together.
Yeah, so started my career at SpaceX. That was really an exciting place to begin a career. Came in around 2007. That was where I first met Erik, and was thrown right into the deep end, as people are at SpaceX. Started there as a lead analyst on the engine programs, doing a bunch of design and analysis for the Dragon heat shield, and really owned a lot of that for a number of years. And that was where Erik and I started working together. He was leading the Merlin vacuum engine program, and I was the lead analyst on that engine program, as well as a number of others. And that was my first exposure to metal additive, which we'll get into more. But then went on to Virgin Hyperloop. Had some former colleagues that pulled me in very early as one of the first hires there. So I got to see and be a part of really building a new company and building a new technology, and learned a lot of, also learned a bunch there on things to do and not to do. And then, Erik and I had stayed in contact over the years, and ended up kind of starting Freeform.
And Erik, I think I've heard of the Merlin engine, so maybe tell me a little bit about your time at SpaceX prior to Freeform, and then let's jump into the creation story. How did you guys come together and decide to start the company?
Yeah, for sure. I want to pause to just appreciate that the statement you just made, that you've heard of the Merlin engine, because for many years, people would ask me around here in Los Angeles, they'd say, what do you do? Who do you work for? And I would say SpaceX, and they'd say, who? What? What's that company? The Merlin engine program, I was very fortunate. Tom Mueller hired me at SpaceX as an intern. Actually, I started at SpaceX as an intern, and as soon as I joined on full time, Tom asked me to lead the Merlin VAC program from the very beginning for the upper stage. For those that aren't aware, that's the upper stage engine for the second stage of Falcon 9. And I did that for many, many years. I'm very proud of that program, the success that vehicle has had. It's a super high performance engine. It's just an amazing piece of equipment. And then the founding story of Freeform is really about, my career was predominantly in rocket propulsion. I mean, I was in the trenches. I'm a hands-on person, developing rocket engines, working alongside some fantastic and smart people, learning a lot. And I saw along the way where we started using additive manufacturing or metal 3D printing, whatever, you want to call it. People refer to it as different things. To accelerate our R&D timelines. And we were printing impellers for turbo machinery on Merlin. And at the time, I thought that was interesting, but not really, honestly, as a outsider, just, running the program and seeing we were getting impellers faster, but they kind of looked crappy at the time. And they still required a lot of there was a lot of manual labor, had a lot of trouble with it. So I didn't think much about it until a little bit later in my career, when Elon asked me to take over the Raptor flight engine program for Starship and Super Heavy. And there, Elon, as he often did, asked for a lot of things that were going to be quite difficult to achieve. and we had to lean on 3D printing to have any chance of getting close to what he was asking for. And we did. And that was the moment for me where I saw the transformative potential of the technology. It was for a very niche application. At what I would argue, space is exciting and interesting to me, but in terms of the grand scheme of the, people in the United States, at least, I don't think it's a thing that they think about day to day. But TJ and I, let me finish the story. So that was where the idea kind of started. And then, I decided to leave SpaceX to pursue, whatever was next for me at the time. I did not know, I was going to found a 3D printing company. I actually got involved with another, co-founding another company out of the Bay Area called Reliable Robotics, doing automated cargo delivery. And John Caloris and Jörg Freifel and I co-founded that company. I never know exactly how to explain it, but my fiance was not interested in moving to San Francisco. So she was very supportive of me, of course, but when it came time to move, she really did not want to go. And, so I decided that was not the right, path to take. And then I reconnected with TJ. We had kept in touch over the years, but, I kind of reached out to him. I had TJ and I felt did some amazing things together at SpaceX. And I thought of in my career, if I was going to found a company, who's a person that I would want to do it with. And TJ was at the very top of the list. So I reached out to him, and it just so happened at the time that he was, thinking about leaving Virgin Hyperloop, which he was an early employee there. And we basically got together and started, talking about where our interests were and our skill sets, and, what might we do together. And pretty quickly, printing came to the top as something that we found, very interesting, had seen, I would say, this is probably true for most founding stories. At the very beginning, you get this very general idea of the direction you want to go, but the details of it are kind of muddy. Like, what is the specific problem you're solving, and how are you doing that? So we spent some time figuring that out, and then decided we had what it took and went out and started fundraising.
TJ, that checks out.
Yeah,
that story checks out. Okay,
that's accurate. Yeah.
So, Erik, I actually have a question for both of you guys. So, Erik, you mentioned that Elon asks you to start working on Raptor. What year was that when you were like, oh, well, we're going to have to 3D print some parts to make this timeline happen?
It was probably 2013, 2014, early 2010s.
So call it 10 years, right? So I'm kind of curious, like, in that time frame, setting Freeform aside for a second, in that time frame, what has happened to metal 3D printing, right? Because I remember there was a time, and maybe it was early as back then, where there were certain there were certain alloys or certain materials that you couldn't that people thought you couldn't 3D print with, like Inconel as an example, and then it became possible. But I'm kind of curious, like, how far has the technology even evolved in that time period?
So that's a fantastic question. I was writing down so I didn't forget to quote you on people thought, because I actually think that's an important piece of this, which is the 3D printing industry. Any industry that predominantly serves, I would say, defense, aerospace, old aerospace applications, is it's unlikely they're on the cutting edge of innovation and scrappiness and speed. There's a lot of, so even to this day, we fight a lot of perception in the industry that is frankly completely incorrect. People say, you cannot do this, you cannot do that, you can't print with this alloy, you can't print with, but if you dig in and you say why, most of the time there isn't a good answer. It's, I heard somebody tried this a long time ago. There was a paper. Okay, what paper? Can you send me that paper? No one can find it. So I think that what has changed, unfortunately, the second part of your, kind of question is what has changed. One of the reasons why we founded Freeform is because not a lot was changing. The machines were getting marginally better, for a long period of time. And I can go into excruciating detail on, why that is. But they really weren't getting that much better. They weren't getting that much faster. No one was really tackling the hardest problems that we needed to solve to enable the step change in performance and speed and cost reduction that will result in widespread adoption. And so, I think that was the incentive for founding Freeform was this technology is going to change the world. And it is a matter of the time scale you put on it. You put some former SpaceX people that, grew up in that environment that don't know anything but first principles, moving fast and being scrappy. Maybe it can be a year or two. You just let the industry do what it's going to do. It might be 20, 30 years. Yeah.
Yeah, you look at that arc of the industry over the last 10 years ago. You're still you're buying $1 million machines, or getting a team of engineering technicians and cranking out a part that might take 17 days to print, and you find out it had failed on day one. You don't know that until you pull the part out, and you lose that part and all that time. So it's quite painful. But yeah, SpaceX is one example of someone who invested a bunch of money and effort into making it work and just kind of brute forcing it with the systems that are out there. But that's not really well replicated across the industry. There's some other companies who have had some success, but we hear so many stories from customers who are still just struggling, and they have machines that they've gotten rid of or are mothballed because the technology and the incumbents just really hasn't progressed.
Yeah, in fact, on that point, Mo, I just want to jump in and add one more thing to that, which was that, if you don't mind, which is, I was talking to someone yesterday about this, an investor, and one of the interesting things is actually companies are so disappointed with these machines they're buying. They get sold this bill of goods that is not what they expect. And so they spend $1 million, $2 million on machines, and then a year or two later, they're selling it for $100,000. And there are now businesses out there that are basically scooping up these machines for pennies on the dollar and then offering printing services at lower prices because they didn't have to pay for the equipment. And the interesting thing there is that doesn't scale. And at the end of the day, the technology is still fundamentally what it is, and they can't scale. So, it's just the whole industry was, even though it's a new industry, was kind of ripe for disruption.
Yeah, fascinating. Okay, so this actually gets me to my next question then. So you mentioned you're kind of alluding to business model. Now you guys take what you've called manufacturing as a service as an approach. So maybe talk about what is Freeform. Let's talk about the business. Maybe let's talk about the business model for a second, but also talk about the technology itself. Like, what are you guys doing that's different?
Yeah. On the business side, parts as a service or manufacturing as a service. Everybody else up until now, or the vast majority of companies out there, have tried to package and sell machines. And the fundamental problem with that, as I think TJ just alluded to, with SpaceX standing up an army of people and expertise, and it taking years to, force these machines into, a state that was useful. Most companies aren't going to do that. And so, that it's just a really, really complicated process. It's much more akin to semiconductor fabrication than it is like metal cutting. And so, as a semi, most companies aren't doing their own semiconductor fabrication. Like, they just don't do that because it is really, really complicated. Metal printing is no different.
Yeah, high precision lasers, very fine powder, inert gas, all of these things that are part of the process. Not to go into all of the details that really actually come through in the printing process. So that's where it's complicated for a customer to take this box and figure out how to use it and make it useful. So at the end of the day, the customers want parts, and the simpler we can make that process for them, the better it is.
And also, the unique part of that is that I spent many years, fighting is the wrong word, but sitting in front of Elon, making proposals, talking about buying more additive machines, and to say that he was unhappy about that situation would be an understatement. SpaceX bought them, but it was kicking and screaming reluctantly because the technology was enabling, but man, Elon did not want to buy machines. And so we had this really, in hindsight, it seems very obvious now to me, and I think to a lot of folks. But at the time, it was not obvious. But it was obvious to us because we saw it firsthand. I saw what a company like SpaceX, who was a power user of additive, actually wanted, which was, as I'm sitting there arguing with Elon, I'm thinking to myself, if there was a place that we could go to and actually buy the parts that we need and have any level of confidence that they were good and usable, we wouldn't be buying these fleets of machines. Because that's not what he wanted. We just wanted the parts. So the business model is definitely something about Freeform that's unique. And I'll say to that one more thing, which is, the selling machines model. I think the current environment, where, you look at all these SPACs. I mean, I would argue I'm not aware of many SPAC successes in general, 3D printing or otherwise, but you just look at the performance of a lot of these companies that peddle these Rube Goldberg machines, and lie to customers, and they're not doing so well. And I think that instead of that being evidence of like, man, everybody else is selling machines, why is Freeform? I use this as evidence that what we're doing is actually the smart thing, because what they were doing clearly didn't work. There's so many data points. If I just objectively look at it, it says whatever they're doing that they have in common doesn't work. And even if I throw the outliers out because they were just poorly run businesses, it's still, there's data that supports the thesis that selling machines is not where it's at. And it's logical that it's not where it's at because it's so complicated to get, the parts off these machines.
Yeah, and then we are really required to make sure our technology is good so that we can deliver good quality parts to customers, because there's no one else that we can pass that buck on to, because we're producing the parts, the customers are getting those parts. There's no one in between, and there's nowhere for us to hide. So that's a big part of our technology and ensuring that we have a good quality process and resulting product.
Yeah, when you're designing, when I was designing Starship, and architecting the super heavy booster and the Mars colonization system in general, Elon was always very, very good at setting high level, very, very simple objectives. What are we trying to do when we're making design decisions on the super heavy booster? A lot of people are like, I have no idea how to think about this. It's really simple. What is the impact of dollars, money per unit mass to the surface of Mars? That's it. Does this increase it or decrease it? If it increases it, it's the wrong thing. So for us, parts as a service is that metric, because it is the thing that actually matters in all of this. The parts that come out have to be good. The customers want it. And then we can't hide. There's no hiding. We either do that and we give them what they want, or we don't succeed as a business, which is the right forcing function to improve the technology, and ensure that we can deliver good.
I want to talk about sort of when 3D printed components outperform traditionally manufactured parts. I want to talk about that, but in the context of a company that has really leaned into 3D printing, which is Relativity. In the early days, they came out and said, we're going to 3D print the whole damn rocket. And now that's not the case anymore. So I'm curious, like, from your perspective, what was the perception even then? That wasn't very long ago, where you were like, okay, well, it makes sense to 3D print everything. And then now the reality is like, wait a minute, it's actually really quite difficult. So I'd be very curious to get your guys' perspective on, because, and I only bring up Relativity because it's such a well-known brand in the industry, especially as a representative of new space and that movement and and the financing behind it. So maybe let's. I'm curious what you guys think about that.
Yeah, I mean, I think I'll take a swing first, TJ, and then you can comment if you'd like. I think that a few things. One is anyone that's ever done anything with hardware in their life, especially in aerospace, is going to know that there's no one manufacturing process to rule them all. So to go into anything saying everything should be 3D printed, 3D printed parts are inherently better, At least today, that is just not the case. There are applications that make sense for 3D printing, and then there are plenty that don't. I do think over time, in not a long period of time, there are more and more applications that will benefit 3D printing. But the whole industry adoption, market adoption of 3D printing is a bit of a chicken in the egg scenario. Customers are not going to design parts to take advantage of 3D printing if there is no capability to use the technology to print those parts at any scale. I would argue, and I would say to kind of support relativity's early thesis that, life, from a first principles perspective, everything, when I move 5 feet, I use energy. And so if I can do something by moving 4 feet, I use less energy. That is more efficient. That is notionally better, at first principles perspective. I do struggle to see really any application out there that would not ultimately benefit from being lighter, from combining components, from being more reliable. But it becomes a price point, and what is the actual tangible value proposition of that advantage. And that's why you see 3D printing adopted in aerospace and defense, because they're not cost sensitive and the performance gains are huge. What other industry out there does it cost $10,000 a pound to get to orbit? So saving a pound to even if it costs you 10 grand, you're neutral at best or worst. So relativity is an interesting use case, and story there that I just think that, applaud. I think they've done good things for the industry. They've in general, 3D printing, just like desktop metal, regardless of what their share price is doing, Rick Fulop did a good job getting printing out there, getting people talking, metal printing, getting people talking about it. I would also say one more thing with relativity is just that they never set out, just like SpaceX, to develop their own actual technology to do printing. Yes, they have Stargate, but it's not quite like what we've done here, which I'm sure we're going to get into. Relativity thing, 3D.
Yep. TJ, anything to add there?
Yeah. Yeah. I would just say you want to be careful that you're not a hammer looking for a nail. And as kind of Erik was alluding to, in terms of selecting the appropriate manufacturing technology for a product or for the engineered solution. So that's one thing. And I think that they've probably learned that over the years and kind of how the company has matured and progressed. But yeah, there's still good use case for additive within relativity for sure. They're making a lot of their engine components that way. Maybe not everything across the vehicle, but they've kind of refined where they are applying the technology a little bit more appropriately, I think. And I think that right there it shows promise for being able to apply additive to other companies and industries as well.
So I want to transition into the actual technology you guys are building, and you guys are quoted in an article saying that SpaceX owns something like 40 to 50 metal printing machines. Our single production prototype can exceed the printed volume of every machine that they own. Love the statement. I want to dig into that a little bit more. So tell me, so obviously it sounds like a massive improvement in efficiency and speed. So what are you guys building?
So I'll say that before we talk about specifically what it is, we built our first prototype high volume production system in about 9 months with about six people. And I don't remember how much we had spent at that point as a company, but I think it was less than $10 million. It was not very much. And I think that really spoke to, that's why we attracted some really fantastic big name investors pretty quickly, even though printing had kind of fallen out of favor in the VC community for investment. But they saw what we were doing, saw the speed we were moving, and saw the product we were developing, and they got on board with it. So now to the specifics. I think that from a first principles perspective, one wants to say, and this is what you're now starting to see the commercial manufacturers do, that adding more lasers makes the printer faster. That is generally true. It should be generally true. More power, is melting more material, and more material melted means the printer is faster. The problem ends up being several things with that. Add lasers, the complexity in which you schedule those lasers and use the lasers basically gets exponentially more complex. So 1 to 2 is far more complex. 2 to 3 or 4 or 4 to 8, it's so difficult to keep aligned with one another, to even just schedule them. There's other factors. What geometry am I melting? Where is it with respect to the flow that's going by? All these other details that make it really, really difficult to use all those lasers. And so, we set out, we built in 9 months the fastest printing platform on the planet that used the most number of lasers. And at the time, and the secret to that was really taking a step back at the very beginning of the company and saying, what is the problem we need to fundamentally solve that unlocks using more laser power? And that for us was what we call real-time closed-loop process control. Effectively, it is a very, very advanced telemetry and feedback system that's running at extremely fast microsecond level timescales that is measuring what we're doing and actively controlling to it. And that enables not only printing faster, I'll make a little bit of a jump so I don't go into the excruciating details, but it enables cross laser calibration that we don't have issues with lasers being out of sync with one another. So positionally or transient. So you now have a system that effectively I can put 32, 64, 128 lasers on and actually use them all. This fundamental cornerstone of Freeform's technology is that. This is why NVIDIA invested in us. We collect, process, control, and process data at I think the Bloomberg, when Ashley Vance was here, I made a reference to, Netflix level data volume moving. It's true. In this little building, that's what we do. And so that's the enabling technology. Then, that is on the quality and speed side. And now we also removed, so I'll tell a quick tangent so that I can put it into context. One of the most important lessons that I learned at SpaceX from Elon directly was that, oftentimes engineers are operating under the wrong assumptions. So in this space, when you come here and visit us and you see what we've built, the very first thing people say, they're like, "Oh, yeah, that makes sense." We basically stepped back and said, "How can I make this process and system far better if I do not have the constraint of having to package a printer in a box?" And as dumb as that actually sounds to say out loud, it enables a lot of things. Because you now are just thinking on in a different dimension, and again, I know it's in hindsight it's trivial, but that's effectively what we've done. Is we've unwrapped the printer from the box and instead said unwrapped it and taken it out of the box and said, let's architect the factory of the future. Let's architect. Everybody says they're building automated factories. I see a lot of pretty things with TVs and displays. I don't see a lot of practical engineering decisions other than, Tesla's Gigafactory and places that are actually doing these things. And that's what we did. So we took the printer out of the box and we've re-architected to maximize throughput and uptime and automation. And developed a modular and scalable platform that we can expand and has the capability of being fully automated. Anything to add to that, TJ?
Yeah. Yeah, if you look at the kind of the biggest problems with metal additive, you can kind of boil it down to quality, speed, and cost. And so we address the quality with the closed loop process control. This is the control that's happening in microseconds at the melts and resolidification timescale of that process. The speed, it goes back to kind of first principles. You want as many lasers as possible, as much laser power as possible, and lasers on as much of the time as possible. And in order to do that, you can't really do that in a conventionally designed or architected system. So that is how we architected our factory production system around making sure that happens, like Erik was talking about with the scheduling and having all of these lasers able to work in concert. The other thing that kind of ties in with adding more laser power is you are also affecting the thermal state of the part, and this actually affects mechanical properties of the produced part and material. So it is really necessary for you to have the process control in order to be able to leverage effectively all of the laser power that is there. And then by doing all that and wrapping it up in this architecture, we're able to really drive the cost down.
So let me try to kind of simplify the system here in layman or lamos terms. I just thought about that. I just came up with that, by the way.
It's great.
If I'm kind of hearing you right, you've created some type of like laser-based or computer vision-esque feedback system, and you mentioned thermal properties. So I'm guessing what's effectively happening is you guys you're able to figure out if the part that you're printing isn't being printed correctly and making those adjustments real time.
Yeah.
So that's what that sounds like. And then I'm kind of curious go ahead.
I was just going to add, it's a slight tweak on that is when it is trending in a direction that will be bad, we make corrections. Once
Correct.
It's bad, you don't want to correct once you're there.
Of course.
Yeah.
So I guess what I should have said, it's like almost like predicting that it's going to be bad and we're going to fix it before it's bad. Okay, awesome. So why is that possible today and why was that not possible? Was it a computing power problem?
Yeah.
It was across the board. Computing power, sensor performance. Wasn't possible.
Brain power. That was something that, the people on our team here, especially that we brought in early, really had a lot of insight. Tasso, former CTO at Velo, Tasso Lapas, was just a brilliant mind in the metal additive space and able to really think about how we could do this. And that just wasn't possible with the compute that you had, 5-8 years ago.
By the way, I hope you've had an opportunity to meet Tom Mueller. He hired me at SpaceX as a mentor and a friend. He is the most brilliant engineer I've ever met. I describe to people, Tasso Lapas for us is the Tom Mueller. He's the Tom Mueller of additive manufacturing.
Amazing.
So yeah.
Sounds like you got a good one then. Okay, so I wanna make a statement, not that I believe in, but it's a statement that I hear a lot. Or I shouldn't say I hear a lot, that I've heard in the past. That's what I'll say. And I want you guys to respond to it, which is true factory scale 3D printing is decades away. Like that is it. That I've heard that in the desktop metals. All during the SPAC craze and why the SPACs ultimate. And we'll talk about that in a little bit. Why you have all these companies that are doing metal 3D printing down like 97-98% because like that factory scale 3D printing vision never actually came to fruition. But I'm curious, that idea that it's decades away. Like, how do you respond to that?
I mean, exactly. Yeah. I think, joking aside, nothing is decades away. Very few things are truly decades away. Especially this one. I mean, come on. I would also say is to support that if people need support. SpaceX is doing it today. Stryker Medical does it today on the medical side of things. They have fleets, hundreds of commercial printers. I don't know the exact number, but I've heard anywhere from 1 to 200 commercial printers. I mean, you're starting to approach like some reasonable capability, even with the crappy commercial machines today. SpaceX is doing it. They're making Raptor engines every couple days. So, if it's 20 years away, really, I mean, no.
Yeah.
And I think the same people saying it's 20 years away are the same people that, when we were starting the company, TJ and I are very, we don't think that our ideas or our beliefs are are necessarily the right ones. We have we have some theory, some thesis that we make, and then we want to go and get information from others to confirm or support or reject this idea. And when we were first founding Freeform, I cannot tell you the sheer magnitude of misinformation that was given to us by quote unquote industry experts in hindsight was shocking. So the people that are telling you it's 20 years away are the same people that are like, you can only print this certain way with this material, with argon and all these things that when you again start to dig into it, it's not based honestly, here's a specific example. There's certain gases people say you can use and can't use for certain alloys. Inconel, the traditional aerospace industry tells you you can only print with argon, only. And the people feel religious about this. And I ask, why? If I use nitrogen, nitrides. Okay, has anyone collected this data? Is there paper on it? No one could point me to it. So, there's people that will adamantly disagree with me on this, but it's you got to do your own investigation and go, collect data and figure out where the truth actually is. And I just think it is not plausible at all that printing is 20 years away. Just because desktop metal, couldn't do it, or relativity is struggling, or these other Velo 3D is struggling. How many electric car companies were there before Tesla? Quite a few.
Yep.
And
That's
space
totally
companies.
Fair.
Yeah. And I'll give an example of, we kind of talked about the throughput of our current system. The next system that we're building out, the first two lines of that will have an equivalent throughput, if not more, of the top 10 printing providers, print shops in the US. So you take the top 10 print service providers that have 10 to 40 machines each, and the throughput of our next two systems will surpass all of those combined. Yeah.
So
it's here and it's coming, and that'll be online. That'll be online the early part of 2025.
So given your guys' backgrounds, I gotta assume that one of the main industry we're focusing on, or sort of the first industry we're focusing on is space, aerospace. Is that the only industry you're focused on? Are there other industries that you're looking at right now?
Yeah, not the only one. Certainly one. There's an existing market there. There's been some success. We're certainly getting a lot of pull from some customers that are in the aerospace, also defense. High performance automotive is another, as well as advanced energy and even semiconductor fab. So quite a few. Those are really at the kind of the forefront of our early go to market. But then we're seeing little glimpse of traction across just really broad industries with oil and gas and other industrial components as well.
And what type? Can you give me a sense of like the types of components that you guys are producing and manufacturing today?
Also, a pretty wide range. The majority probably fall in some of the kind of like fluids and gases and heat exchangers and manifolds and things of that sort. Especially if we're talking about engine components, injectors and nozzles and all of that. Then it also varies into just brackets and kind of structural components as well.
And just to kind of maybe switch gears and talk a little bit about the business itself and the business model, how do you generate revenue? How do you work with customers?
So customers, we've got a few kind of buckets of customers. Those who are looking to replace traditionally manufactured part that they are looking for some of the benefits that they get from additive by having a part consolidation or improving their supply chain, reducing the number of parts, that sort of thing. Then we have those who are have a brand new part introduction, new product development, new product introduction, and those are where we're seeing a little bit more success. And typically those are applications where they're better able to leverage our technology. So yeah, when we engage with customers, sometimes they have the additive design already in mind, and sometimes they lack that and are looking for a little bit of help there, which we provide. We have people on our team that design rocket engines at SpaceX and elsewhere, and know how to design for additive and to design leveraging our technology. So we can give that feedback to customers, really help them on their journey in getting into additive, and get their part files in the door, and then we basically take care of the rest. So get it ready for our production process, generate the build files and tool pathing. Customers don't have to worry about any of that. We have some post-processing capability on site here as well, where that includes some surface finishing and heat treat and post-machining, and can deliver parts to customers to their drawing spec.
Or I was going to add to that. Let me just jump in. I want to add one more thing to that, which is just that, generally speaking, I think virtually every actual customer we have business with them has grown. So, once we start delivering parts to them, they recognize the value proposition. The feedback we get is overwhelmingly positive, frankly, across the board. Part quality, finish, speed in which we deliver, every price, everything, the level of engineering assistance we can give them, and then they come back. And we are signing master service agreements with several of these big customers, or have signed them, with steady production deals and revenue growth into next year and long.
Yeah, we have a great example. We have a great example with a defense customer who had a part that was somehow produced, held up overseas or something like this that they couldn't get, and it was holding up their engine from testing, and called us in a bit of a frantic panic. And we were able to turn around that part in 3 days. They were able to integrate it on their machine, on their assembly, and get their engine on the test stand like the following week, which before they contacted us, they didn't think they'd be able to. And then we're able to, a few months later, ramp up into hundreds of units per month, and really just go from this one-off and now into production pretty seamlessly.
I want to talk about the scaling of your operation. So you've mentioned that the unique sort of perspective you have is unboxing the printer, right? And maybe talk a little bit about, like, if you can give us a sense of scale of the level of production you guys have today versus what the factory of the future looks like. Maybe talk a little bit about that. What does that look like?
Yeah, the analogy we usually use for this is sort of the AWS data center analogy. We tried to architect a modular and scalable platform that we could, scale out. So you could have a small data center, a big data center. You could have a small factory, a big factory. And so, yeah, that's on the kind of scale side. I don't know, TJ, do you have things you would add to that?
Yeah. The vision's to really distribute those around the U.S., around the globe, near the point of use of where our customers are located, and have these lights out autonomous printing factories that are just cranking out parts, and building in as much automation into that as possible to really control the process and have this go seamlessly. And today there's still elements that are somewhat manual that we're already improving more automation into the current system, into the next system. So taking methodical steps towards that.
Yeah, I guess one other thing I'll say I just thought of is that, sorry, Mo, the other thing to give people a visual, the vision is always that there's a dump truck that backs up to the one side of the building, and the back of it is full of powder, and it just like dumps it into a giant hopper. And then out the other side, there's like a little conveyor belt with parts just like falling off into boxes,
The grain silo, yeah.
There you go.
Yeah.
So I want to ask a little bit of a, I don't know if it's let's call it a spicier question. And for those who know me, know that I love spicy questions and spicy food. But I want to ask about, okay, so you've raised north of $50 million from like some pretty great investors, right? Threshold, Founders Fund, Two Sigma, NVIDIA is now in your round, amongst another, a couple other strategics. There are a number of companies out there that are building automated factories right? And the fact, and what I would, call, again, the quote unquote factories of the future. For the investor listening to this to this show, what do you say to say, hey, like, this is what you need to be looking out for when you're talking to those types of companies to like really see who has a technology that can scale, and what is more, call it lipstick on a pig, for lack of a better word or lack of a better term.
Yeah, this is a great question. TJ kind of said it earlier. One of the things that we see, I certainly see, and I would say I'm kind of a technology skeptic in general. So when I hear the buzzwords, that's why Freeform has been flown under the radar for the most part, because, I just don't lean into the best, to be honest. Um, you have to be really careful about the hammer trying to find the nail. Um, Factory of the future, automation. Elon has said this many times too. Automation you do last. The reason why some of the things that we do here today are still manual frankly, because we didn't know what it was going to look like. And so, I remember years ago, quick anecdote, visiting McMaster Carr. A bunch of us went over to McMaster Carr because we wanted to just get try to understand, what an operationally efficient company. And we wanted to kind of see that firsthand and see how they did it. And one of the things that surprised me when I visited them was very few robots, a lot of human beings. And when I asked why, they said, because when the economy slows down, a robot can't repaint the bathroom or mow the front lawn. And I thought that was just very interesting.
Yeah.
So, I think that everybody wants to lean into, factory of the future, automation, all these like buzz phrases. And I think that you have to understand what the market opportunity actually is and what the use case is. Are we automating for the sake of automating? Because sometimes, especially, here's another like really important piece, which is, some things should not be automated. There are some things that should not be automated. And you have folks that get so wrapped up in this idea of automation that they try to automate everything. And that is a mistake. Because if you understand how there's several really good books about these kinds of things, but if you understand how this whole thing works, it's like a house of cards. And if one step is broken, the whole thing comes to a screeching halt. And so, you have to be very, very careful about that. So, my advice for them is to come invest in Freeform. Come see what we're doing and invest in Freeform.
Yeah, I have a few thoughts too on that. One of which, you look at some of these images of the factory of the future, and you'll see kind of robots driving around the floor that open up a door handle that's clearly made for a human, and that just seems, not designed from the ground up in the right way. And you're putting this very expensive piece of equipment to do something, like Erik was saying, that could be easily manual. That's one thing. Another is a lot of this automation is kind of around workflows, and that there's not necessarily a huge kind of IP or tech differentiator with a lot of that. That can be beneficial for sure to have some of this workflow efficiencies, but that's not really the full automation. And then another thought is that a lot of these things are designed for the human interaction and not easily automatable. That's actually quite a challenging problem to go solve CNC machining and automating. We've talked to some of the companies and founders that have started these companies and struggled and failed, and it's because of all of the corner cases. And there's a number of examples where you just need a human in order to interpret that. And the thing with additive for us is it's inherently just because it's a digital process, starting with a CAD file, and you're building this thing up layer by layer. The machine doesn't care about tooling, stock material, any of that sort. It's all in our process and it's inherently automatable. So that really gives us a significant leg up on the ability to automate our production process.
I was going to ask about the public metal printing stocks, but I actually think you've convinced me as to why they are actually doing as poorly as they are. So I want to talk about the future. Are there what role do you envision 3D printing to have? Kind of how do you think that evolves in the next decade? Are there emerging materials or printing techniques that you're very excited about?
For sure. I think that one of our early investors, after they invested in us, shared some comments. Some discussion topics they had among a group of folks that I very much respect and think are quite smart and make very smart investments. And one of the questions that they fundamentally asked each other was, do you fundamentally believe or disbelieve that more things will be 3D printed in the future? And it's like clearly believe. And it becomes as you got alluded to before, a question of timeline, and what additional capability and technologies are required. Ultimately, there's a $1 trillion market opportunity or more. And I'm being, I'm not sitting here and telling people I don't like inflated market numbers. But I think if you objectively look at the global metal manufacturing market, and sort of loosen, let's not overly judge based upon what the technology is capable of today, but let's make a somewhat subjective assessment of what could be printed and what could benefit from printing. I have done this exercise, TJ and I have. It's like $1 trillion of opportunity. So today the market is, billions, single digit. So the penetration of additive is small. How do we make it? How do we expand it into so we can start to capture this? It is making the surface finishes better. It's reducing post processing. It's having a multi-material capability. So these are the things I think. Another kind of interesting thing that I'll talk to folks about is this idea that, when you buy 316, you've probably heard of 316 stainless steel, right? What exactly is that? It is a name that we have put to a bunch of constituents that get mixed together and turned into this material, and then we call it 316, and it has this, these properties.
Because it's formed in some certain way too.
Yes, these materials and these specs and these properties, these materials were not developed for the additive process. The way in which you mix and make these things actually does matter. The reason I bring that up is I actually think there's a huge opportunity for innovation, especially for a company like Freeform. This is really the secret. When I'm giving you little stories of what we investors that we're not very public about, which is, I think we have the ability and knowledge, capability of measuring and seeing and interpreting things in this process that actually allow us to develop new and cutting edge alloys and materials that are game changing. In addition to the technology, the capability of the actual technology to disrupt, now you're talking about new materials. So this is what got me, I get asked a lot, TJ and I get asked a lot about, how did we go from a career at SpaceX? Why would I have chosen on my own accord to leave SpaceX and end up, figuring out colonizing Mars and end up here? Because I truly fundamentally believe, I of course believe colonizing Mars is important, and I hope Freeform plays a role. We are playing a role in that. The possibilities here for just massive innovation and disruption of industries with additive is enormous. It's hard for folks that don't live it and don't see it to see that today, especially given where the commercial machines are at. But I think that the future is going to be an amazing place with what we're going to be able to do. TJ, go ahead. You see, TJ always says it better than me.
You hit all the big points. The material, the opportunities for material new alloy development is a big one. That's really exciting. With the sensor technology, control technology that we have, we're barely even scratching the surface on what we will be able to do there.
So I have two more questions I got to ask, but I'm going to give you my last question first, not to answer, just to think about, which is I want to hear your best or your favorite story from your SpaceX days, especially since you guys were in there in the early days. But don't answer yet. The question, and Erik, you kind of gave me a little bit of a lead in on, is what do you think off-planet 3D printing is going to look like? I mean, how important do you think is that going to be for our desire to be a multiplanetary species?
I mean,
Erik has a very specific example of this. Yeah,
I do. It's clearly going to. Again, are we going to do more or less 3D printing in the future? We're clearly going to do more, and I think that this idea. I mean, at the end of the day, it's really simple. Think about going to Mars, and are we going to bring with us? Does it make sense to bring with us, gigantic sheets and plates and bar stock of every different alloy and material we might possibly ever use, then the equipment to manufacture that, then the equipment to recycle that, because we're certainly throwing the chips into a Mars landfill, and the energy it will take to do that? Or are we going to figure out how to unburn the rock, pull the constituents out of that, nuclear power, and then turn that into the materials we want and use just what we need? If I'm starting a civilization and colonizing a planet, those machining away 90% of the thing seems like not a great strategy. And then all the way to, there's the use the Martian sand and soil and rock to print, huts out of the regolith, and there's all sorts of crazy ideas that I think will not be crazy actually. So yeah.
Yeah, Erik's being humble because he was leading the early Starship architecture, and that was one of the thought processes was, once you're on Mars, what are you doing when you're there? And 3D printing certainly is something that is going to be increased use on Earth as well. I mean, very low waste process, virtually no waste at all. So. It's going to be a very efficient process and way to make things as we continue to ramp this up.
Yep. And I mean,
Very
you see
well
it, Starship and Raptor use tons of printed parts.
Yep. All right. So favorite / best stories from your SpaceX days. Go. I want to hear from both.
I'll go first.
You go first.
So early morning, I get a phone call from Erik, actually, which he's calling me from the Cape. Because they took some closeout photos and observed some anomalies on the nozzle extension for the upper stage engine, which I was the analyst design on. So turns out we found some damage there, and we had to scramble to get up into the vehicle and cut the nozzle off with tin snips and convince NASA that this was acceptable, perform some analysis up all night, kind of making sure everything was hunky-dory there, and we're able to have a successful launch.
What year was this? I feel like I've heard I feel like I've heard this story.
It's in Berger's book too. It's in Reentry.
Yeah. I think it's in one of those Netflix documentaries. I think the story's in there. That's actually great. Great.
Yeah.
It was a stressful day, but yeah, I mean, the team always just rallied. A fantastic team. We were able to run a bunch of analysis and present that to NASA, the range, to convince them that it was safe and we would still be able to accomplish the mission. So, yeah,
I think awesome. That was the same. Did you tell the part about the champagne, TJ?
No.
the rest of that story.
That's right, yeah.
The rest of that story is kind of cool, which was it was like kind of surreal. So, I was in the control room at the Cape, and after the first couple launches, they were so important. We had these gigantic bottles of champagne that, once it was like, all right, we've succeeded. By the way, as the RE, the owner of the second stage engine, was really crappy because anytime we had a coast and a relight, everybody from first stage is celebrating, and I have to wait like an hour. I'm like, guys, be quiet. We're not done yet. So that flight was successful, and I call TJ on the phone, just be like, "Yo, man, it's successful. It's amazing." And as I'm talking to him, I grab this giant bottle of champagne and I take this like big swig of it, and then I just hear on the phone through the mic on TJ's side the crowd like just cheering wildly. Yeah. TJ's laughing, and he's like, "Dude, you are on like center in the feed coming back to Hawthorne." So everybody at SpaceX that was watching is seeing me like chug this champagne, and everyone's like, "Yeah!" So that's awesome. I thought that was pretty cool.
That's awesome.
I don't. All right. Yeah.
Good.
Oh, I was just going to say, I don't know if I have, I have, of course, lots and lots of stories, tons. Like a lot.
The question is, which ones are podcast appropriate?
Yes.
All right. Well, all right. You guys give me a pretty good one, so we can leave it at that. But no, in all seriousness, guys, this was a great conversation. I feel like we could have talked for 2 hours. This was very exciting. Thank you for being on the show, and very much looking forward to seeing how you guys are. Actually, maybe one last thing, like, are there any milestones that we should be looking out for? Like, as people are following the company, as people are like, all right, like, what's next for Freeform? Anything that's coming up that folks should be paying attention to?
Yeah, I think there's going to be some big announcements over the next couple of months about growth and trajectory of the company. And like TJ said, next gen platforms are coming online they're going to be starting to come online into this year, into early next year. And I think, when we're talking about the entire, the 10 highest throughput capable service providers in the United States, when Freeform can exceed that right here in Hawthorne as a single provider, this starts to become game changing. And so, I think stay tuned for some big announcements on the customer side, and some partnerships and some really, really exciting work that we're doing.
Amazing. We're looking forward to it. Thanks, guys. Thanks for being on the show.
Yeah. Thank you,
Absolutely.
Mo. Appreciate it.
Thanks, Mo.